Good morning, students. Today we'll see some numericals in DC motor. First one, find the useful flux per pole on no load of a 250 voltage 6 pole shunt motor having a two circuit connected armature winding with the 220 conductors. At normal working temperature, the overall armature resistance including brushes is zero point 0.2 ohms. The armature current is 13.3 amps at the no load speed of 908 rpm. Solution. If the V is equal to 250 voltage, number of poles given is 6. Number of conductors Z is equal to 220. All this given the data. 220 conductors. A is equal to 2. RA is equal to zero point 0.2 ohms. IA is equal to 13.3 amps. N is equal to 908 rpm. For a DC shunt motor, V is equal to EB plus IARA. When you substitute all these, you can find out what is the back EMF. Since the terminal voltage V is given as 250, IA is given 13.3, RA is 0. 0.2. That can be substituted in this expression and EB can be calculated. Back EMF EB is given by EB is equal to 5 Z10 P by 60A. By using the first equation, EB is calculated. Then using the expression for the EB, there all the terminals, all the parameters other than 5 it is known. When you substitute for that, you can calculate the flux. The question asked is find the useful flux. So V is equal to EB plus IARA. Using that, you calculate the EB. Then go for using the expression EB is equal to 5Z NP by 60 amps. In that, by substituting all the values, you can find out where phi is only the unknown. You can find out the value of the phi. Next. Here 240 volt 4 pole shunt motor running at 1000 rpm gives 15 horsepower with an armature current of 50 amps and a field current of 1 amps. The armature winding is wave connected and has 540 conductors. Its resistance is 1.1 ohm and drop at each brush is 1 voltage. Find the useful torque, total torque and useful flux per pole and the rotational loss. V is equal to, given value V is equal to 240. Number of poles given as 4. N is equal to 1000 rpm. P out is equal to 15 horsepower. IA is 50 amps. I shunt is 1 amps. RA is 0.1. If wave connected, A is equal to 2, Z is equal to 540. That is also given. V brush is 1 voltage. Brush voltage or drop across the brush is also given. It is 1 voltage. Make use of the formula. Useful torque, that is the shaft torque, is T sharp. TSH is equal to P out by omega. So P out by omega, when you substitute 15 into 735.5 into 60, omega is 2 pi n by 60. So P out already it is given as 15 horsepower. To convert that into watts, it is multiplied with 735.5. So 15 horsepower it is given. To convert the horsepower into the watts, it is multiplied with 735.5. So we will get the torque as 105.35 Newton meter. Total torque in the armature is given as power developed by the armature divided by 2 pi n by 60. Power developed by the armature can be given as EB into IA. So where EB is equal to V minus IA RA minus brush drop. By substituting for IA, RA and the brush drop and also for the V, we can calculate EB. that is 230 voltage. Then torque is equal to EB into IA by 2 pi n by 60. So by substituting all this, we'll get it as torque as 111.2493 Newton meter. By using the formula back EMF is equal to 5 ZNP by 60 ohms, where A is equal to 2, we can calculate the flux, which is the unknown here. Next, the rotational loss. The last torque is equal to rotational loss divided by 2 pi n by 60. So, by substituting for that, we'll get it as torque is nothing but 111.29 minus 105 into 2 pi into 1000 by 60. Next one, a 120 volt DC shunt motor has an armature resistance of 0.2 ohm and shunt field resistance of 60 ohms. It runs at 1800 rpm when it takes full load current of 40 amps. Find the speed of the motor while it is operating at the half full load with the load terminal voltage remaining the same. Solution: shunt I shunt can be given as V by R shunt. Using that, I shunt can be calculated. V is given as 120 voltage and shunt field resistance is given as 60. Using that 120 by 60, you will get I shunt current as 2 amps. Phi is proportional to I shunt. Here phi is constant. Torque is proportional to Ia, that is proportional to phi. So T1 by T2 is equal to Ia1 by Ia2, or T1 by 0.5 T1 is equal to Ia1 by Ia2. So Ia2 is 0.5 Ia1. IL1 is equal to, the load current 1 is equal to I shunt plus Ia1. Ia1 is equal to 40 minus to 38 amps. Ia2 is equal to 0.5 into 38, 19 amps. See, back EMF 1 is equal to V minus Ia1 RA, where Ia1 is 38. So when you substitute for that, you will get it as 140 minus 38 into 0.2, that is 112.4 voltage. EB2 is equal to V minus Ia2 RA, where Ia2 is calculated as 19. 120 minus 19 into 0.2 gives you 116.2 voltage as EB2. N is proportional to EB by 5. That is proportional to EB, since flux is constant. So you can write it as N1 by N2 is equal to EB1 by EB2. So and substitute for EB1 by EB2 and N2, we can calculate for the speed as 1860 rpm. A 500 voltage DC shunt motor has 4 poles and a wave connector winding with the 492 conductors. The flux per pole is given as 0.05 Weber. The float current is 20 amps. The armature and the shunt field resistance are 0.1 ohm and 250 ohm respectively. Calculate the speed at the developed torque. Solution: given V is equal to 500 voltage, number of poles is equal to 4, number of conductors is equal to 492, and phi is given as 0.05 Weber, and the line current IL is equal to, the load current IL is equal to 20 amps. Shunt current can be calculated as V by RSH. Here V is 500, shunt resistance is 250 ohms. So shunt current is 2 amps. IA is equal to IL minus I shunt. IL is 20, so 20 minus 2, 18 amps is the armature current. EB is equal to V minus IARA. When substitute for V and IARA, I will get it as 498 voltage. EB is 5 ZNP by 60 amps, so A is equal to N is equal to 60 into 2 into 492, 98.2, so 607.5x. So torque is equal to, using the torque equation, 0.1595 into IA into Z P by A, we'll get it as 140.810 Newton meter. Thank you guys.